I'm Konstantin, and this talk was generated in collaboration with Jasper as well as Karel. We are all engineers at ML6. Who is ML6? Well, we are an AI and machine learning services company. We have over a decade of experience in AI engineering as well as in AI strategy, and we help our clients build scalable, future-proof AI solutions using technologies such as Apache Beam. Now, if we look back at the title, we see at least three parts: Superpowering, we have agents, and also we have Apache Beam. What we will be seeing today is an example use case. We will talk about LLMs, we will talk about tool calling, we will talk about agents, and then we will put these things together, mix in some Beam, and then we have Beam agents that we superpower. All right, let's kick it off with the use case. So let's assume I have a candy company, and we were really lucky because the company went viral, and we have a lot of orders that are coming in, and they are through the roof. Now, we use internally Apache Beam for a lot of workflows, and it's really great. And recently, I've received many urgent emails that need to be addressed. And one of the questions that I need to have answered is, what is the total spend of customers that ordered by one of these emails? But I need it really urgently, so I cannot wait for my engineering team to actually build a pipeline that addresses this question because they're all at the summit. So let's figure out how we can actually do it. If you look at the problem, maybe a pipeline solution could look as follows. So we have some unstructured data. This is my emails. Then we extract some information from it using an LLM. We then have these augmented emails. We filter them. We enrich them again with the customer information. Then we also combine it with the order information. We do some grouping, and then at the end we can sum all the totals of all the orders from all the different customers, and then we have our answer. Now, if we look at the use case, what do we need to do? At least a couple of things. We have unstructured data that we need to process. We need to enrich it with structured data. We need to do some aggregations, and we need to do it to gain insights and to be able to take some actions because we have a lot of emails. And we need to do so without the data team. Now let's talk about LLMs, tool calling, and agents. The solution to this problem is easy, right? Just use a chatbot. Well, we could do that. We could figure out something with maybe Gemini or ChatGPT. But the problem is, even if the agent or the LLM was able to generate my pipeline, I wouldn't be able to run it. Or you might say, okay, but just use GitHub Copilot or Cursor, use an IDE, you can do it, it can maybe even run it and debug it. That might work, but I'm a non-technical person, so I don't want to even touch any code or see it even. So how can we do it? I think LLMs are still the right way to go. They have amazing capabilities with text generation, images as well. They can consume and produce structured output. They have multimodality, they have text really understanding, and recently, they also have code execution, reasoning, tools like web search, and we have specific models for coding challenges. And if we look a bit at the spectrum or continuum of LLMs on the left-hand side to agents and multi-agents on the right-hand side, we can see a couple of things. So if we take a vanilla LLM, we can get an answer from it, but the answer is just based on what the LLM knows. If we do some clever prompting, we can already get some more things out of this LLM. Another thing is augmentation. So if we provide in our prompt already some additional information, that has two benefits. First of all, I can inject knowledge that the model doesn't have intrinsically. And also, it makes the model be grounded in this information that I provided. Then we have techniques like chain of thought. So if I tell the model, hey, do it please step by step and think a bit about what you want to do, I also get better solutions. Now, augmentation is a bit, I already need to know what I want to introduce into my prompt for it to be used. Another evolution of this is tool calling. So for example, I can give a bunch of actions that the model can do, and it is then free to choose whichever is appropriate. So I don't need to predefine it. With this, I can already make certain workflows, and that already enables a lot of different or more complex problem resolution. And recently, we also have reasoning. So that is basically building on the chain of thought, but also having very specific models that were trained on a data set that is already chain of thought, plus on problems for reasoning. And with these things, I can do planning and I get to agentic workflows. And we have seen in a previous talk from Charles already how we can integrate this into Beam. Now, if I take all of these, I get to agents, and we will see this shortly. And if I take it even a step further, we get to multi-agents. So let's look very quickly, how does it usually work for agents? Basically, here's a very simple example for a weather agent. I give it a prompt. I say, hey, you're a helpful agent. Your objective is to complete tasks from users. And then we say, hey, you also have these tools available. For example, get the weather, and you need to provide the city name or the chance of rain, and so forth. And if we now look at an example interaction from the user, it might ask, hey, what's the weather in New York City? The LLM says, okay, I don't know this. I need to call a tool, get weather for New York City. Then we need to generally call actually this function to get the weather. And then we have this information, we inject it back into the prompt, and then the LLM can answer the question because now it has the knowledge that it needs. Now we can do the same actually for a Beam agent. We basically define the same thing. We say you're a helpful agent. Your task is to complete objectives from users with Beam, and you have the following tools available. You can list data sets because, I mean, we want to solve real-world problems and we don't want to predefine what knowledge you need to use, so we need some access to data sets. You need to at least create a pipeline, you need to run the pipeline, and you probably need to read the results because then the agent can also answer questions from the outcome of the pipeline. So let's put this into practice. Basically, I probably want to define a couple more tools, and I wrote them down here. There's probably a bunch missing, but starting with the top left, we have this write pipeline. We need to run the pipeline, for example, locally, or we want to submit it to a cloud runner, and then we need to have some way to submit it and probably also monitor the progress of the pipeline. Then it helps if we have predefined pipelines to be able to actually take parts or the pipeline that is already predefined because we know that these ones work well. And similarly, we want to predefine maybe sources which already work, and I think with some new developments in Beam that gets even easier. And then similarly, we also want to predefine or have a library of predefined transforms. They can be regular transforms, can be enrichment transforms, can be stateful transforms or transforms with side inputs. I think that is all very good to have as a repertoire. And then additionally, we also have the data sets again, so we know where to get the data from, and that can be different sources, can be files, can be networks, can be databases, can be hierarchical ones, can be vector stores, and so on and so forth. And then secondly, we also want to probably list certain other services, for example, APIs. And then we have two additional ones here. One is web search and bug fixing. So if we run a pipeline and the agent realizes, hey, that actually didn't work, we want the agent to be able to debug and fix these. And for this, it's probably good to have access to the internet. And then another one is looking up documentation for Beam. So that is already available. So why not tap into this and restrain already our web search to the good quality. Okay, let's do this. So the code actually looks rather easy for all of these different tools. So here, for example, we have something for the run Python pipeline. Really important here is that we clearly define in the docstring what the tool does, what it's for, what the arguments are, what it also returns, such that the LLM can handle the inputs and the outputs appropriately. Because that's one of the important things. If we have an LLM that wants to use a tool, it not only needs to choose which tool actually, but it also needs to assess, does the user input already contain enough information to use the tool? And can it extract the right information to then inject into the tool call? And if there's not enough information available, it should probably recognize this and ask the user for more input to be able to call these tools. And then here we have basically very easy logic, just import something, run the pipeline. If it works, great. If it doesn't work, then return an error. And then we can do this for the other tools as well. So for example, here we have something for writing a pipeline. And again, the most important thing is actually just having this docstring correct. And we can do it also with our reusable transforms. So if we have a library, we can say, hey, get these ones, and you get a list of the transforms that are already available. And we can do the same with our Python pipelines. And we can do the same with our data sets. and we can do the same with certain APIs. So for example, one of the problems that we encountered in this demo that we will see later is that it hallucinated which LLMs it calls, but it's really important if you have, or if you want to incorporate services that actually these exist, and also that you have access to those. So it's probably good to predefine this and constrain the models that it doesn't make stuff up. Okay, now we have defined all our tools, and that should be sufficient to basically have our agent, right? We can do that. If we do it, it will probably involve a lot of code to actually interact with the model. Get the tool call, execute it ourselves, have some structured output again, provide it to the model needs to incorporate it, so there will be a lot of back and forth. We don't want to do it. Instead, we want to use the ADK, the Agent Development Kit from Google. And that one is great because it provides a nice to have features. It has a UI that we will see shortly. It simplifies the tool calling because we just need to give it basically the function name, and it extracts already the doc string and all of these things, and it also executes actually the function calls. We can define multiple agents so that we can say a tool can also be a different agent so that they work together. And then there's some nice features like evaluation, memory, sessions, and we can very crucially incorporate planning. And for the ADK, it has this plan, act, observe loop. How does it work? Basically, it's based on a paper called React. And in this paper, they propose to couple reasoning and acting. Acting is our tool calling, so we choose something that we want to do with the environment. We do it, and then we observe the results. And then always we have this loop that we want to reason about the results. Was it correct? Was it not correct? Do we need to do something different? Okay, now we have built this, and the UI basically looks like this. It's very nice. We have on the right-hand side this very common chat interface. On the left-hand side, we can choose different agents. And then I can ask my question, what we want to do, and the agent will do it. Now, how do we define the agent actually? It's very easy as well. We give it a name. We describe a model that is doing this reasoning loop. Then we have a description, and we have some instructions. And here we can see, okay, one of the instructions is, for example, don't make up code. If there is something that you can reuse, you should probably do it. Or if you find an error, use some of the tools that you have available to fix these errors and run again. So you really want to be descriptive. And one of the things that I have not done here, but that you should do, is already describe all of the different tools and when to use which in what situation. Then I also give it all the tools. In this example, we have 4 different blocks. One is for listing data sets and reading files. So we have data sets. We can read the entire file. We can also list results. Then we have a bunch of Beam-specific tools, reusable transformations, example pipelines, also the pipelines that have already been generated by the LLM, as well as the available LLMs. And then we have something where we can write pipelines as well as execute them. And we have this special agent, which is for searching. And one thing that we still want to do here for this planning loop is basically define a planner and give it a certain budget that it can consume during this thinking phase. All right, so let's do it, the demo. Our use case objective, basically 3 points. First of all, at the end, we want to have a single pipeline that can be executed. And this pipeline should process the received emails, so that's unstructured data, and return the total spend for all customers within these orders, or for customers whose emails were orders. All right, let's do it. So I just prompt the LLM or my agent now. Can you write a pipeline in Beam that reads all the emails? And we already see here that I broke the problem a little bit down. You don't have to do it, but in this case, we will see the example where I've done that. And then the LLM will respond, and it lists the data sets. It views some data sets to see, okay, how does the data actually look like? We list example pipelines. We say, there's one that is interesting because I need to do something with LLMs, and there's one that is called LLM transform that is already predefined. That's probably useful. We read the example pipeline. We do some planning where we say, okay, create a pipeline, modify something, use call Gemini text or a variant thereof, define a prompt for this, write to extract the data, and then also run the pipeline. Then the LLM will write the pipeline, it will run the pipeline, it will list the results, and it will read the results. And then it evaluates the results, and it runs the full pipeline, because often in these flows, I found that actually it tries to run the pipeline only with a subset of the data, which is already a good call. We would probably do this ourselves. And then at the end, we run the full pipeline and we can confirm success. Now, how does the code that is generated look like? Well, here we have a predefined, not a predefined, a generated transform to call Gemini. And it has some helper functions, but otherwise it's just a process, and there we make the LLM call. It's probably not the best way to do it, but it is a way that is viable in this use case to do it. And the rest is just a function for run, where we define the pipeline. We match some files, which is all of our emails. We read the matches, we call Gemini, and we write down the results again. So pretty simple. We can also visualize it. Looks like this. All right, 1 point already down. Process the received emails. Next up, I say, okay, let's also do the rest of the thing. So categorize, combine it with orders and with the users, because the emails don't necessarily have to be already containing all of the information that's relevant, like customer ID or something like this. I follow the same way, and the LLM will go in its loop and says, okay, read some customer data, read some order data, read a join pipeline, because I need to probably join some information at some point, and I found this example that already exists to do it. I do a plan, and this plan basically has 3 steps. Create a new pipeline, customer order analysis, then read the data from 3 sources, and then perform the following steps, which is basically filtering and combining. Then I will write the pipeline, I will run the pipeline. In this case, we realize, okay, the pipeline actually failed because the path was incorrect. Then we run it again with the correct parameters. We read the results. We analyze another error. There was a key incorrect. We write another pipeline. We run it. We read the results. We realize, okay, something was still wrong, because in one of my data sets it's called customer ID, and in the other one it's called buyer ID. Okay, not a problem. Write a new pipeline, run it, read the results, and sorry, missed the last step. Read the results, and basically, okay, now it works. And we can again look at the code, and we have one function and otherwise a pipeline where we do a couple of things. We read certain data sets, categorize emails, customer profiles, the order ledger. We have then the orders, that is a combination. We have the customer orders, and we have the customer order totals, and at the end we get the correct thing. And if we visualize the pipeline, this looks like this. It's a large thing, starts out with 3 different data sets, does a couple of co-groups, mapping, flat map, and so on, some filtering, and at the end we get the correct result. Is this the optimal pipeline? Probably not. Okay, 2 things. One thing down, we now have two pipelines, and we wanted to have a single pipeline. We can do that as well, so I say, hey, can you also actually combine this, so we don't have this intermediate file. It will make a plan to create a new pipeline. It writes a pipeline, it runs a pipeline, it lists the results, and in this case, it actually worked out of the box, so we're done. And we see here, it basically combines the entire pipeline. And again, we have these different blocks. All right, done. Now there's some good and some bad. The good thing is the agent was able to solve our use case, but oftentimes it's not in a single go. So here also I chopped the problem up into 3 pieces, and then it actually worked. Then a good thing is with these Beam tools, we enable data processing at scale, and we can take advantage of all the robust built-ins. Then next, example transforms help. In another run, I did the same, and I explicitly instructed, hey, please, if there is anything, use existing transforms, and there was already one predefined to call Gemini, for example, for this augmentation, and it used this by just importing the correct transform, which is pretty nice. Then, really crucial, defining tools correctly is key, and it requires iteration. So you probably don't get it in one go, because there's a lot of prompting going on, so you need to iterate on this. Then Python pipelines work better than YAML, and this is a bit in a contrast with the talk from earlier where we heard that YAML was actually working quite well, so I'm really curious what the problem is. I have some ideas why that might be the case, but let's take it as an observation. And then the other good news is data engineers are not yet obsolete, because generally I present it here as something where we start naively, we don't want to see any code, but generally we still want to do validation, and also it works better if we do it step by step. All right. If we want to take it further, we can do a couple of things. We probably want to define more tools. So for example, a library for transforms, or this tool that I alluded to earlier where we say, okay, actually search the documentation. We might also want to combine certain tools. So for example, if we realize that two tools are always called one after the other, it doesn't need to be two tools. We should probably combine it. And then what we have seen here is only with a local runner. We probably also want to have cloud runners and then streaming pipelines, which introduces a lot of complexities. Because if we say, okay, we have with Beam the ability to run pipelines at massive scale, that also means they won't be done in a couple of seconds, but rather they might run for hours or days, and then we need to check in on the progress. And that gives us also another point on the right-hand side, proactive reporting. Maybe I don't want to have some kind of event system where the agent lets me know when something is actually done or some intermediate results are available. Another thing that we have seen already is we probably want to standardize these tools by using MCP. I think that makes a lot of sense. What we haven't seen here is also evaluation, which is a very interesting topic for these agents, where you really want to focus on what I mentioned before, that you have these steps where you want to call a tool and you need to assess, is all the information available and how do you do it, and can the model actually extract the relevant information. And then lastly, I would say Beam schemas is probably a really good thing to have or be able to take even more advantage of already predefined transforms, because then you can chain them much more easily together. Okay, food for thought. How can we make frameworks successful in the era of AI-assisted coding? I have some thoughts, but given the time, let's move on and summarize what we have seen today. So basically, we have seen some definitions of tools and what they enable. They enable LLMs to act. We have seen that reasoning and planning are really key, but with these you can solve complex tasks. We have seen how we can define tools for Beam specifically, and with these tools we superpowered our agent. And we have seen that tool definition is really crucial, and we also have seen that human in the loop and step-by-step instructions are still super relevant. Thanks.